match the list 1 with list 2 and select the correct answer. Okay, now list 1 A is discontinuous conduction of current. Okay, we have to match with list 2. Okay, when you have discontinuous conduction of current, what does it mean? That current is reduced to 0. Okay, on x-axis. That means if you have discontinuous current conduction, power delivered to the load, okay, power delivered to the load is reduced. If power delivered to the load reduced, okay, power factor reduces. That means it is having poor power factor. So A is 3. Now next one, in list 1 B, he has given source inductance of the converter. Okay, now when you have source inductance on the converter side, okay, now what is this one? Since this is inductor, inductor will absorb reactive power. That means it is acting as sink. Okay, this is a coil which is acting as sinks. What does it mean? That this reactor will absorb some amount of reactive power. That means we have to provide additional reactive power from the source. Okay, so B is 1. Use of freewheeling diode, okay, and symmetrical angle control. What are the advantages of these two? Okay, here if you see symmetrical angle control, when you use symmetrical angle control, displacement power factor will be better. Okay, what is displacement power factor? Displacement power factor is angle between fundamental voltage and fundamental current. Okay, when you use freewheeling diodes, displacement power factor will be unity. Okay, so option D is correct answer.
Question is, consider the following program instead to transfer block of 5 bytes from A00H to 9000H. So if we go through the program, we are going to understand that here BC register pair, which is loaded with the 9000H, as well as same C register is also used as a counter. So there is a confusion between the counter as well as the address. Hence, so we cannot use the C register as a counter because we are using that to store load the address as well. Hence option A is wrong one. Hence option A is true.
200 kilowatt 400 volts 14 pole DC machine has a lap wound armature with 1100 conductors. Okay, this is lap connected armature, so number of parallel paths A is equal to number of poles P. Okay, which is equal to 14. Now full load armature current, we can find it from the rating of the machine 200 kilowatt. So this is 2000 kilowatt, not 200. 2000 kilowatt. Okay, so 2000 into 10 power 3 divided by 400. Since it's a DC machine, no need of power factor. Okay, 5000 amperes. Okay, we'll get 5000 amperes. That is full load armature current. Now armature ampere conductors per pole. That means per each pole how many armature amperes, that means mmf is taking. Okay, so armature ampere, okay, conductors per pole. This is Ia into Z by A into P. Okay, now from this Ia we found it as 5000 into number of conductors given is 1100 divided by number of parallel path, which is equal to number of poles. So this is 14 into 14. Okay, now what we have to find here is we have to find compensating winding conductors per pole. Okay, before finding that, what is armature conductors per pole to be compensated by pole phase winding? Okay, that we have to find. So armature conductors per pole to be compensated by pole phase winding is, he has given pole arc by pole pitch ratio as 0.7. Okay, this is pole arc by pole pitch into 5000 into 1100 by 14 into 14. Okay, now this is equal to 0.7 into 5000 into 1100 by 14 into 14. Okay, now the compensating winding carries the entire armature current of 5000 amperes. Okay, what does it mean? That compensating winding conductors per pole, which is equal to 0.7 into 5000 into 1100. Okay, total current is 5000 divided by 14 into 14 into 5000. So this we can calculate as 4. Okay, therefore compensating winding conductors per pole is 4. Option B is correct answer.